Hello once again. Today we're going to have a little classic teardown here. I've got this Morse Electrophonic electronic calculator with automatic shutoff. Picked up this baby at a second-hand store for a whopping $3. It's actually in pretty good condition, despite the fact that apparently it's from like the 70s or something. I mean, like all the silk screening here, it's all like intact. Everything here is fine. I mean, it's a little dusty, but I mean, what can you expect from something that's been sitting around with a bunch of other stuff? The buttons, they all feel nice. None of them stick or anything. All the labels are like in really excellent condition. I mean, it hardly looks like, I mean, if you didn't know any better, you'd think this label was new. Well, newish. It's got like a few little blemishes on it, but it's not that bad. See, the text on here in the back is fine. On the back, it's got instructions. This is a very basic calculator. It only has like 4 functions. Model number is CAL-801, and I couldn't really find a whole lot of information on this from doing a quick search. This label right here is a little scratched up, but I think that's probably because it was sitting on like a pile of a bunch of other junk. All the little feet are still intact. It's just, I mean, all around, it's like just excellent shape. It's got this carrying strap. And I mean, you can still even see the texture on that, as you can see right there. Like, none of it looks worn down, which makes me think that, you know, it's probably like just was purchased and it just kind of sat somewhere and like nobody really, I mean, if they used it, they didn't use it like a whole lot, and maybe it was just, you know, just sat somewhere after a while. So I think the fact that it's got this strap is actually pretty funny. It's got this little swivel on it. It's got like a little key ring. So since it's a portable calculator, I guess you could have been out somewhere, you know, strolling around with your snazzy new calculator. Suddenly you decided you needed to make a calculation for whatever reason, and, you know, you have it on you. Do your calculation, figure it out, you're all set to go. So, as I mentioned, it's a pretty good shape. I put some batteries in it. It takes 4 C-size batteries, so I mean, this thing weighs a ton. It's pretty heavy, especially with the batteries. The foam inside here is a little bit tore up, but I mean, that's no big deal. All the batteries face the same direction, so that means that they're probably using like say this is the negative terminal and this is the positive terminal. Then I mean, if they're in series inside, then that means they have like a wire going from here to the back, you know, and then from here to the back, from here to the back, so that way you get your positive and negative 6 volts, if that's what it's using. I have no idea. I haven't taken it apart yet, which is why we're here. We're gonna take it apart. So, I don't know, maybe let's do a little demo of the functions here so you guys can see how this works. It's actually pretty funny. It's got, well, I mean, it's not funny, but I mean, I guess it's useful in certain situations. But you turn it on, you can see that it uses a VFD, a vacuum fluorescent display. It seems a little dim, and I don't know if it's going to be evident in the video here, but it doesn't look like the VFD is like straight up. It kind of looks like the characters are at an angle like this, because well, I hit the 6 there, but like the 0 looks like it's kind of at an angle. Like I said, I don't know if we're going to be able to tell in the video, but I guess we'll find out once we actually open it up. I'm really curious to see what the VFD actually looks like, and I'm also curious to see what kind of voltage, or yeah, what kind of power supply they're using to step up the voltage to the vacuum fluorescent display, because I'm sure it uses more than 6 volts. It's got this little switch right here that has 4, 2, and F, and what that does is it allows you to set where you want the decimal point to sit after doing a calculation. So let's say you're multiplying pi times, we'll say 3 or whatever. If you have it set to F, then it'll do like all full significant digits, you know, after the period that it can handle. So you do that, and you know, it gives you all the digits after the period. If you do 2, it limits how many digits it'll show after the period. So let's do that again. And then times 3. See, now it only gives you 3.4 or 9.42. And if we do it to 4, then obviously we're going to get 4 digits after the period. So 9.4248. So that's kind of interesting. You can, you know, set the limit of how many significant digits you want. Put it back on full, and then it's got this other little button here, or a switch that says K. That one, what it allows you to do is multiply continuously by whatever number you entered first. So like, say we do 3 times 6. okay, you get 18. If you hit times again, we'll say 3, then it should be 9. So it continuously multiplies by whatever the first number you entered is. So let's do it again. Let's do 8. Should be 24. 24. And then it's got this other little section here that says sign. And it actually tells you on the back what the signs mean. So if it's a exclamation point, that means battery low. Negative, then obviously a negative. It says C or E. Entry overflow display, blah blah blah. It's got a U or an O. Result overflow display. It's got this G or a 6, 0 or an 8. This G or 6 means entry overflow, result overflow, and 0 or 8 it says same as above plus battery low. So that's it. Like I said, very basic in functionality. It doesn't do like a lot of like modern funky stuff. So I don't know, I guess that's a good enough review on it. Let's go ahead and take it apart. After removing the batteries, you can see that there's a serial number in there. Well, I'm assuming that's a serial number. And even that label is fully intact. And there's actually a little piece of packing peanut or styrofoam in there, and it just fell inside. So, okay. So it's got 4 screws. You got 2 here, 2 in the front. After removing those, we should be able to get in there pretty easily. I doubt there's anything else holding it shut. So there's all 4 screws. Turns out that the ones in the front are longer than the ones in the rear. So that's easy to keep in mind. Now the back comes off, and I guess we'll lift it off this way. And sure enough, as I expected, they've got the wires running from positive to negative, and they are all connected in series. So I'm wondering why they didn't just you know, do what's normally done, where they'll have like a spring on one side here, and then the contact comes over to the other side for the positive. Seems like it would have saved a little bit of having to cut up all these wires there, but I mean, whatever. I don't know what kind of limitations they had at the time. And there's the main board. It looks like it's all kind of coated with like it's all templated or with solder or something. And there's a connector down here on the bottom. Look, it's a cartridge connector. So I have a feeling this should just pull off, and there it goes. Sure enough, everything looks like it's in a pretty clean shape, so it looks pretty nice. It looks like we'll be able to take off this board once we remove these 4 screws, and this apparently looks like it holds a lot of the with some of the logic. The one in the front looks like it's just nothing but switches. So maybe since I removed this connector here, this whole board maybe just comes right off, and there's nothing else connecting it to the other board up in the front. Right here it looks like we've got a bunch of sort of circular components. I don't know what those are yet. Maybe that's the apparently that goes up to the vacuum display. So it looks like I might need to take off these 2 screws here, and then this whole assembly should come right up. So let's go ahead and take those off. And I'm trying not to damage this as much as possible, because, you know, I'd like to keep it intact and, you know, still functional. So that's all those screws. Let's see if this comes off now. And there it goes. Oh wow, it's not even like a whole display. It looks like it's almost kind of like a little Nixie tubes that it uses. Yeah, each one of those is an individual tube, and if we look in from the top here, you can see them. I totally wasn't expecting that. I thought the whole thing was just like going to be like one tube, but I guess now that I think about it, when you looked at it from the front, you could kind of tell that there was like a line like reflecting off of each one like that from the front. So I guess that could have been a dead giveaway that it was small little, well, I mean, they're not really Nixie tubes. I guess they're more like vacuum fluorescent display tubes, but there's just a bunch of individual ones. So that's pretty neat. I totally didn't expect that. Looks like this right here is the step-up section for the tubes, because there's a little, looks like to be a little transformer there. You got these transistors here with these heat sinks, and then we got a bunch of other transistors right here. These are probably going to be the drivers for the tubes. We've got a couple pots here. Apparently those are glued down, so they're set to whatever they need to be. This apparently is the main controller for this whole calculator. It's a TMS 0105NC, and that looks like it's made by TI. Got a row of diodes down here on the bottom. You know, resistors, other diodes right here. These are probably going to be like rectifiers for the step-up section, I'm thinking. Looks like it might be. So yeah, very old school design. Oh, and a date code of 31st week of 73. So yeah, this is definitely from 70s, early 70s or so. So, well, let's take a look at these tubes a little better. We got 4 screws right here. We can get inside and look at them. Okay, so there we are. I've removed the 4 screws, and now this little sort of like bezel up here in the front should come right off. And there it is. Oh, and it let the back off too. Ha! You can kind of see that these were glued in place. That's glue right there apparently. And it's actually pulled the numbers off of the tubes with it. At least I'm hoping that's what it is. I'm hoping they didn't break. No, they didn't break. So yeah, these were glued in place, and the glue over time, I guess, just kind of separated. It took the numbers with it. So that's that. I'll see if I can figure out what these numbers were supposed to be, and it looks like they were made by NEC. The numbers here are backwards, but, or I mean the letters are. But yeah, that's the back of the tubes right there. That's pretty cool. They're pretty long. They're about like an inch long each. I'm trying to be really careful here not to drop any of this stuff. I really don't want to break these things. So wow, let's get a little bit of a close-up on here. And there's a shot from the rear with the macro lens so we can see things a little better. You can see all the individual leads coming in from the bottom and going to their respective spots for each segment on the display. And it looks like the number's supposed to be LD83015E, I think. Just from what I can see on these numbers, it looks like that's what it's supposed to be, but I'm not 100% sure. So then once again, here's a close-up of the board. That's where all the displays are soldered to. And that's the front of one of the displays right there. You can see the grid, and then each digit underneath it, or each segment underneath it. And apparently these tubes have kept their seal pretty well. There's no cloudiness or anything up there on that getter. That up on top there is just white paint. So yeah, they're in pretty good shape. So that was a look at the main board inside this unit. I really didn't expect there to be an IC in a socket like this, but this one was put in a socket. I'm not going to bother removing it because it doesn't look like there's anything interesting underneath. So now I'll just let it stay inside. And then on the keyboard, I don't know if there's going to be much interesting going on in there. I mean, it's just the switch matrix. These two, the switches up at the top, they're actually pretty big for, you know, they look kind of small from the top. Well, I guess not that small, so I guess not too surprising. But this one here is using only 2 of the 3 positions it has. So apparently when it's all the way to the far right, which would be the full digits or the full significant digits, there's no connection here. And then when you move it over, it looks like there might be, it goes to the second one, and then when you move it over one more, then it goes to this one right here. So this one up here is probably the main one, and then this one, it's either on or off. Even though this one looks like it's supposed to be a 3-position one too, I guess maybe they had these and they just, you know, to prevent having to spend money on like a separate type of switch with only 2 positions, they just decided to stick with the same one, and then they just limit its motion by cutting it out right here up on top. Because it looks like there's another little piece on the bottom plastic there that's only got the cutout like enough for this to move like one spot over. Everything else just looks like they're little push buttons. This connector here, this card edge, goes to all these little wires here soldered onto the bottom. And nothing else much look like going on here. We got the battery coming in. And then here's the push buttons. You can kind of see them sticking out when you push it there for on and off. Here comes the port for the external power supply. Well, I guess we can look underneath. I guess no harm in taking these off and looking at the switch matrix. So we got the screws off of the keyboard here. So now this should just, I believe, lift off. This top here looks like it had it was just mounted to a, or was just holding a little bracket onto it. So I didn't bother taking those off. But there we go. There's all the buttons and switches. And that's what I was talking about there. It looks like this, see how this cutout is smaller than that one. So that would be just to limit the switch from going into its third position that it's got available. As we said, you know, these two switches were identical. It's just that this one can move all three positions and this one can only go 1 and 2. These buttons almost look like those kind of old school keyboard buttons, except that they're in blocks. Like this is one whole block right here for all the numbers, and then for the operations right here, you've got this little block of 2 by like 4, and those are held in place with. Well, this one's held in place with 4 screws right there. So I don't know. Let's just take that off, and we'll take a look at this one. I mean, the other one's going to be pretty much the same thing, so I'm not going to bother. Okay, took the 4 screws off of that, and here it comes. Oh, so that's all it is. So this just fits over the top of that, and then these are the actual switches. So it looks like, okay, so all it does is when you push one of these buttons, it's got that little sort of a keyway right there. Well, that little piece that kind of sticks out, and it's angled like that. So what it looks like it's doing, and let's look at these a little bit closer here, is that when you push one down, it pushes up against the contact there, and it pushes it up against the other side. So every time you push a button, it just makes contact against those 2 points right there. So that's all they're doing. It was a little bit more basic than I thought it actually was. And as far as the power buttons go, all they're doing is they've got a little tab that's comes from that point right there, and it makes contact with one underneath it when you push the button down. As you can see right there, it's moving. So that's all it is. It's not any actual like switch. It's all just kind of like built onto the board. Alright, so before we wrap this up, I thought we'd take a look at see what kind of voltages we're getting out of that little transformer. And it looks like this may be the cap that stores the voltage coming out of it to drive the segments on the displays. So I'm going to turn it on, and it's still working. As you might be able to tell there, it's kind of hard to see, but there it is right there. We see that it's on. So let's see what kind of voltage there is here. Looks like this is negative, this one's positive. Weird, that's only reading, it's actually dropping really quick, so I don't know. Oh, what is that? That's weird. I would have expected there to be a higher voltage there. I don't know why it's just kind of dropping after I touch the leads to it. Yeah, it's continuing to drop. So I have no idea why. I mean, I would think that whatever voltage is supposed to be there should be constant. But, I mean, it's not like it stopped working. Let's see, let's hit 8 a bunch of times and... Nope, it shut off. So we got 8 there. I wonder if this cap stores an initial charge when you first turn it on, and then as the voltage on it drops, that's what times the auto shut off function. I just realized that because I think it turned off just now. So let's let it drain for a little bit and see if it turns off. Right now, as you can see, well, I mean, it may be hard to see, but I have all 8s on the displays there. And let's see if what this voltage goes down to. So now it's down to 1, a little less than 1. It's still dropping, 0.6, 0.5. Yeah, it just turned off. So when it gets to about 0.10 volts, this calculator shuts off. So this cap right here is being used as the sort of like a timer for when the calculator should shut off. So it only stays on for a matter of, you know, for like less than or maybe like about a minute or so. And I was wondering, I thought maybe that was like, you know, something that was controlled as part of the main chip here, but apparently it's not. It's just basically an RC time constant with this cap. So it charges it up, and then it just waits for it to drop below a certain voltage, and then that's when the calculator just shuts off. So that's pretty interesting. I totally didn't expect anything like that. So somewhere along here we've got to have the step-up voltage for the displays here. And on the back, I don't want to tear any of these wires here, so I'm trying to be really careful. Let's see. The diodes are right here, and it looks like this one and this trace going right here are going to be the positive and the negative for the output from the transformer, because the transformer leads on the top side go to those diodes, and then those are connected together here like they're part of the bridge. So maybe if I connect it across those, I'll be able to figure out what voltage it's putting out. Let's see, I'm going to try to lean this forward, and I'll turn it back on, and let's just check the voltage across those two traces and see what we get. Alright, so that's on. So this is one of them here, as you can see, and this is the other one. Aha, there it is. So it's running off of about 13 volts. So that's what it uses for the segments on the little tubes. And then the filament voltage is probably going to be around 6 volts or something like that. They're probably just running that straight off of the battery. I'm not too interested in that one. I just wanted to see what kind of voltage they were using here. So yeah, obviously this is a little step-up transformer, and that's what they're using to drive the vacuum fluorescent displays. So, well, I guess that about wraps it up. I mean, there's really not a whole lot we can do around here. And I hope you found that interesting, and if you like this kind of stuff, remember to thumbs up, and thanks for watching once again.